We're moving on to something new this time, exponential functions. We've been working in linear functions up till now, so let's have a look at the difference here. So what is an exponential function? A linear, which you know, is a straight line, and those lines have the same slope all the way along. So thinking about if you were walking up this line as a hill, it's the same steepness the whole way along that line. But an exponential equation or function, it will increase or decrease dramatically as the x values increase. So notice on the linear as we're going along and the x values increase, it's the same steepness. But have a look at the line of an exponential growth function here. If you're walking along this line, fine to start with. There's my stick person there, but oh my goodness, it increases very rapidly, and we call that it increases exponentially. That might be a word you've heard before, and so that's called an exponential curve. A bit of theory here. So it's a function in which the variable appears as part of the index or the exponent. You've done index laws before, so that means the power. So the x, when we're used to seeing it in a linear format, the old y equals mx plus c, have a look where the x is. You know, with numbers that could be 2x plus 3. So the x is on the same level, as you like, as the y, but this time round in exponentials, it's in the power. That's where the x sits. So here are some examples. Y is equal to 3 to the power of x. That's where the x is. This one here, y is equal to 5 times a half to the power of x. So sometimes there's a number multiplied by it. Noticing that where the x is with, the base that we call it there, so that the base here is a half. Sometimes that's a fraction, which is less than 1. Or in the case of this one, the base, which is 1.5, is greater than 1. And the power or exponent is x. And again, it's multiplied by a number, in this case, a quarter. But just pointing out, this one over here is actually multiplied by a number. It's multiplied by 1, because any number multiplied by 1 stays as itself. We tend not to write the multiplied by 1, but that one's going to become quite sort of important. I'll just tell you straight away, it's the y-intercept number. So we'll come back to talking about why that's the case. So the format for exponentials, as you can see here, it's a times by b to the power of x. So that's the format that it's in. And as the x value increases by 1, y is multiplied by b. These are the values going here. So these x powers here, as they increase, what's happening to y? And then the y value when x is equal to 0 is a. So what that means is when x is 0, that's b to the power of 0. If you remember your index laws, anything to the power of 0 is 1. So that is a multiplied by 1, which is just a. So the value of y when x is 0, so that would be the y-intercept, is just this a number of the equation. Okay, let's have a look at this in a bit more detail. Let's practice some of the algebra first before we get to the graphing in the next video. So substituting in numbers. When you're asked to evaluate, which means work out, the exponential function here for these different x values, all we're going to do is substitute in that x value. Now, if you're in Year 11 General with me, use your graphics calculators. And what you need to do for that is on your run screen, you're going to do 7 to the power of 2. And if to the power of 2 is fine because that's one of the options that you've got. But if you're not sure if it's a power other than 2, you'd use, we call it the hat button actually. So 7 to the power and then you put 2 in and then we get 49 for that one. What about when it's to the power of 0? Again, using your calculator, put that in, 7 hat 0, or you may remember that anything to the power of 0 is 1. What about negative numbers? Yep, we can do that too. Using your graphics calculator, it will just tell you that it's 1 on 7. Bit of a side note, if you've got some background in this stuff, to the negative power means that we actually put it underneath a fraction, so we flip it. And so it's 1 over 7, and then the negative power disappears because it's become a positive. Now it's in the denominator. And then what about two fraction powers? That's okay too. Using your calculator, it will tell you that that is the square root of 7. Some of you may actually also remember that to a half power is a square root. What about another one? Notice that the 7 here was a whole number, a number greater than 1, and this time we're using a fraction, a third, which is less than 1. So they're the main two scenarios that we do here in exponential functions, things greater than 1 or less than 1, so between 0 and 1. So I want to always make sure I try and show you each of those examples. So this time round, we are doing a third to the power of 2. Again, use your calculator and it will tell you that it's 1 on 9. Or you may also remember your index laws that that's 1 on 3 squared, and hence the 1 on 9. To the power of 0, a third to the power of 0. Always good to use brackets. Anything to the power of 0 is 1. Or use your calculator in the run mode. To a negative power, not a problem again. Your calculator will tell you that that is 3. The algebra behind that is that it's 1 on 3 to the power of negative 1. And then we can bring that up to the top and make it a positive power, and that's 3. But again, for my class, just use the run mode on your calculator. And then this one here, to the power of negative 3, is giving us 27 for that. Or it's the same as 1 on 3 to the negative 3, which is 3 to the 3, and that gives us 27. So that's how we would use the algebra for this. Doing a table of values. There is a menu in your calculator that you can use to do this, but I'm going to show you how to do it algebraically, which we were practicing just before. So we're substituting in all the different values of x. So let's do that one at a time if we like. This first one is 40 multiplied by a half to the power of 0 in our run mode will give us 40. Moving along, the next one, 40 multiplied by a half to the power of 1 gives us 20. Moving along, 40 times by a half to the power of 2 gives us 10. Can you see the pattern that's happening? What do you predict the next one's going to be? Check it on your calculator. You don't have to write this all down each time. Just on your calculator, go back and change the power each time and see what happens. Then we get to 5, and then we get to 2.5. And then sometimes you'll be asked to copy and complete a sentence. As x increases by 1, what is happening to y? What would you say? What is happening to these y values each time? You probably would say they're being halved. And another way of saying that is actually being multiplied by what? If they were doubling, I'm sure you could say, oh, that's being multiplied by 2. But when you're halving things, you're actually still doing a multiply, but it's actually multiplying by a half, which is the same as dividing by 2. But getting used to this idea of what y is being multiplied by is really helpful for exponentials. And lastly, this is the question that I want to do, but then I'm going to go back to the table that's at the top there. So when you're asked to consider the table of values alongside here, is there an exponential relationship between x and y? And you have to explain. So when you get a question like this, what do? Just double check that the y is incrementally increasing, so that's going up by 1. What's happening to the y? So we start with 135. What's the connection as we go to 45? That one might be a bit hard to see because that's a big number. What about 45 to 15? How are those numbers connected? How do you move from 15 to 5? What did you do to the 15 to turn it into a 5? Hold that idea. Does the same thing work to turn that 5 into a 5 on 3? 5 divided by 3? Yes, I'm hoping you'll agree that there is a connection here. The same thing is happening between each step in the table of values. And how do you explain that? Here's what you would write. Yes, as x increases by 1, y is multiplied by, and you're probably thinking, well, it's being divided by 3, and hopefully you remember from the last one that we did, it's multiplied by 1 on 3. In this case, the other one was 1 on 2. That's the sentence that you would write. And then for part B there, find the equation of the function connecting them. So an equation is going to have an equals. Where's y going to go? That's on the left. Now think about where the x is going to go, in the power. Exponentials have a multiplied by b to the x. So we're going to have a multiply. X is going to be up in the power. Let's have a think about what the other ones are going to be. You might need to go back in the video and look at the previous table of values and look at the numbers that they had there. And where was the half? So where's our third going to go? That's the one that's connected to the x. So that's 1 on 3 is going here. And there's a number that goes there at the beginning there. That is the value of when x is 0. Now, conveniently in the table of values, we have when x is 0. That's 135. So it's the starting point, if you like, the y-intercept. That's the number that goes here in the equation. 135. This particular one we've just done is where the base is 1 on 3. So that's a number between 0 and 1. I want to take you back to this top table of values because the base number there is going to be greater than 1. Let's see if we can work that out. Having a look at what's happening here, if we had to do the same question again, is there an exponential relationship between them? What's happening here? Explain your answer. And you would say, as x increases by 1, I'm just going to write this underneath here in green, as x increases by 1, y is multiplied this time, this is the same table of values from before, by a half. So for the equation for this particular one, we can start already. We've got the y, we've got the base number to the power of x. What is the number when x is equal to 0? It's this here, it's 40. So there is our equation, 40 multiplied by a half to the power of x. These questions connect to 13b. Thanks for joining me.